Hello everyone! I hope you are having a fantastic day. Today I would like to discuss OSPF authentication, of course with configuration example. In this video I would like to speak about Plaintext OSPF authentication, MD5 OSPF authentication and HMAC-SHA OSPF authentication. So let's get started. So today I want to cover such questions as why do we need OSPF authentication? So why do we need to use it? What is the reason of using authentication for OSPF? I'm going to explain Plaintext OSPF authentication, MD5 OSPF authentication, and HMAC-SHA OSPF authentication. Then I'm going to show a few commands for validation and troubleshooting, and at the end I'm going to show a configuration example. So why do we need OSPF authentication? An attacker can forge an OSPF packet or to gain access to the network. He can manipulate the routing table and as a result can send traffic down the links that allow for traffic interception, create a denial of service attack, or perform other malicious behavior. In order to exchange routing update information in a secure manner and prevent mentioned attacks, you can enable authentication in OSPF. OSPF authentication can be enabled on interface-by-interface basis or for all interfaces in an area. Password can be set only at an interface parameter and it must be set for every interface. There are three types of authentication, plaintext and MD5, described in RFC 2328, and for these two types of authentication, if the password is missed to set on the interface, the default password is set to a null value, and additional HMAC-SHA authentication type for OSPF version 2 from RFC 5709, and this authentication type is available since EOS release 15.4.1t. So plaintext authentication uses simple clear text password, and anyone who has access to the link can see the password using sniffing tools. It is used when devices within an area can support the more secure MD5 authentication. To configure plaintext authentication for an OSPF area, use the following command under OSPF configuration: area ID authentication. And the following command you need to use to set plaintext authentication and to set plaintext password on specific interface under interface configuration: IP OSPF authentication and IP OSPF authentication key. And here you need to specify your password for OSPF authentication for this interface. MD5 authentication uses MD5 hash, so the password never sent out the wire. This technique is more secure and widely accepted. This authentication uses the contents of OSPF packet and a password to compute MD5 hash. This hash value is transmitted in the packet along with a key ID and non-decreasing sequence number. The receiver, which knows the same password, calculates its own hash value. If hashes are equal, then authentication is successful. To enable MD5 authentication for an OSPF area, use the following command under OSPF process configuration: area ID authentication message digest. And the following commands under interface configuration: IP OSPF authentication message digest, and then IP OSPF message digest key. Then you need to specify key number and MD5, and the last one is password for OSPF authentication. HMAC-SHA authentication provides stronger authentication than MD5. The OSPF version 2 cryptographic authentication feature allows to configure a keychain on the OSPF interface to authenticate OSPF version 2 packets by using HMAC-SHA algorithms. For this authentication, you can use an existing keychain that is being used by another protocol, or just create a keychain specifically for OSPF version 2. A keychain can be described as the list of keys, where each key consists of a key string, password, or passcode. Key string is an essential element of the key. Each key is identified by unique ID, which can be in range from 1 to 255. Each key has to be configured with the cryptographic algorithm. The combination of the cryptographic authentication algorithm and the key is known as a security association. The authentication key on a keychain is valid for a specific time period called lifetime. There are two configurable lifetimes in the SA. First one, accept lifetime, the time interval within which the device accepts the key during key exchange with another device. Second one, send lifetime, the time interval within which the device sends the key during a key exchange with another device. The send time of the new key should be set to a time in the future before which the same key should be configured on all devices in the network. On the received packet, the key ID is used to fetch the key information. If there is no key ID, the packet is dropped. When keychain has more than one key, OSPF selects the key that has the maximum lifetime. Key having an infinite lifetime is preferred. If keys have the same lifetime, then the key with the higher key ID is preferred. If OSPF version 2 is configured to use a keychain, all MD5 keys that were previously configured using the IP OSPF message digest key command are ignored. To configure HMAC-SHA authentication, first configure the keychain. For that you need to use the following commands. First one, keychain with keychain name. Here you need to specify the name of your keychain. Next command that you need to issue, key with key ID, where key ID can be in the interval from 1 to 255. For this key you need to specify key string or your password. This can be done with the command key string and then you have value password. Next command that you need to issue is cryptographic algorithm, and then you need to choose one from the HMAC-SHA 1, HMAC-SHA 256, HMAC-SHA 384, HMAC-SHA 512 or MD5 algorithm. Next two commands are optional. First one is access lifetime. Here you have value start time, and then you need to choose one of the following: duration value, infinite or end time. And the second one is send lifetime with value start time, and then you need to choose one from the following: duration value, infinite or end time. If you don't configure these two commands, if you don't use them, then keychain is going to be configured with default values for your key, like always valid and valid now. To configure HMAC-SHA authentication on the interface, use the following command under the interface configuration: IP OSPF authentication keychain name. These commands I will use in my configuration example. If you are enjoying my video, I would like to ask you to subscribe to my channel with the notification bell on. To verify OSPF authentication settings, use the following command: show IP OSPF interface, and then you can specify interface on which you want to check OSPF authentication settings. For example, here you can see that simple passport authentication or plaintext authentication enabled on the interface gigabit 02 on router R2. For router at R3 we can see that there is MD5 authentication is enabled, and for router R1 HMAC-SHA 512 with keychain Cisco OSPF authentication is enabled on this interface. In order to capture and troubleshoot authentication process, use the following debug command: debug IP OSPF adjacency. To summarize information discussed in this topic, I would like to do configuration example. For this example, I'm going to use a topology with 4 routers: R1, R2, R3 and R4. I'm going to configure multi-area OSPF for this example, and I'm going to use plaintext OSPF authentication between routers R1, R2, MD5 OSPF authentication between routers R2 and R3, and HMAC-SHA OSPF authentication between routers R3 and R4. Okay, this is my network for configuration example. I already pre-configured all IP addresses on all interfaces on all routers, so I can focus only on OSPF configuration and only on OSPF authentication. So I'm going to configure Plaintext OSPF authentication between router R1, R2, MD5 OSPF authentication between router R3, R2, and HMAC-SHA OSPF authentication between router R3, R4. So let's get started. Show IP interface brief. We have IP interface up, router OSPF 100, network 10.12.0.0.0.0.255 area 1. Let's go to router R2, conf T, router OSPF 100, router OSPF 100, network 10.12.0.0, area 1 and network 10.23.0.0, area 0. Let's go to router R3, conf T, router OSPF 100, network 10.23.0.0, area 0 and network 10.34.0.0, area 0. Let's go to last router. Show IP interface brief. Router OSPF 100, network 10.34.0.0.55, area 2. Show IP OSPF neighbor. Sorry, I think I made a mistake. Yes, no, area 2. Now let's wait until routers form adjacencies, so we can check that everything is working fine before we start OSPF authentication configuration. Still nothing. Show IP OSPF neighbors. This router already good. It's formed OSPF adjacencies with router R2, and the last one, router R4. Still nothing. X start. Now it's good. Full. Show IP route OSPF. We can see our routes to our network 1, 2, and 23. Okay, router R1 is going to have Plaintext OSPF authentication with router R2. Conf T, area 1 authentication. Oh, sorry. Router OSPF 100, area 1 authentication, and then we go to interface G01, IP OSPF authentication, and IP OSPF authentication key, and let's specify our password or key is gonna be Cisco. Let's go to R2. We're going to lose adjacency with router R1, R2. We're going to lose adjacency between these routers because one router has password, the other one doesn't have it. Router area 1 authentication. You see, we lost adjacency. Authentication, interface G01, IP OSPF authentication, and IP OSPF authentication key Cisco. Let's wait for our neighborship adjacency restored to show IP OSPF neighbors. We can see that everything is fine between these two routers now. And for this router I need to configure MD5 OSPF authentication on interface G02. So I go to router OSPF 100 and I need to add command area 0 authentication message digest. Then we go to G02 interface and we use command IP OSPF authentication message digest, and then IP OSPF authentication message digest key. Then we need to specify key ID, then it goes MD5 our hash algorithm, and then we need to specify password. It's gonna be Cisco. Let's go to router R3, area 0 authentication message digest, interface G01, IP OSPF authentication message digest, IP OSPF message digest key 1 MD5 Cisco. To show IP neighbors. To show IP OSPF neighbors, sorry. As you can see, everything is fine at this time. So we lost and we restored adjacency once I had configured the password for this interface. So now we need to configure keychain for OSPF authentication between router R3 and R4. Keychain, let's say Cisco, use capital. Then we need to specify our key number 1 and key string. It's gonna be also Cisco. Then we need to specify cryptographic algorithm. We have many options. I'm going to use HMAC-SHA 512 and interface G02. We need to specify that we use HMAC-SHA for OSPF authentication on this interface. IP OSPF, we have option authentication, and then we have option keychain, and then we just specify the name of our keychain. And let's go to last router R4, show IP OSPF neighbors. We still have neighbor router R3 for R4, but it's gonna lose this adjacency once the timer decreases to 0. Let's wait. 5, 4, 2. Okay, no OSPF adjacency with router R3. Conf T, keychain, Cisco, and then key 1, key string, Cisco, cryptographic algorithm, HMAC. I'm going to use, I have to use the same, otherwise it's not gonna work. And interface G01, IP OSPF authentication, key chain Cisco. So IP OSPF neighborship. As you can see, we have adjacency with router R3. Everything is fine. Show IP route OSPF. We have our routes. So all our authentications are working fine. Let's see what's gonna happen if we change, for example, if you made mistake in key. I'm going to change it to Cisco 1. And let's input command debug IP OSPF adjacency. And let's see what it says. And as you can see, we have mistake error mismatched authentication key clear text. So let's go conf t interface G01 IP OSPF, and we also lost adjacency. POSPF authentication key Cisco. Now it's gonna restore adjacency. To show IP OSPF neighbors. Everything is good. Let's say you forgot to configure your authentication key. In that case, it's gonna use plain text or just empty default password. Again, we have error mismatched authentication key clear text. Let's go to router R2 and we can change here. Oh, sorry, it's already exists, so I need to delete it first. No, and then to configure again. Debug POSPF adjacency. Let's see what it says. And it says that mismatch authentication key router interface G02. Let's fix it, but I need to delete it now. And last one for keychain. For keychain, for example, to make keychain HMAC-SHA authentication work, you need to use the same key ID and key string on both routers. Let's say I forgot that and I configured two keys, key ID. I'm going to configure key ID number 2. Keychain Cisco key 2, and if there is the same times for let me show you. Show keychain. As I mentioned in the video previously, if there is the same accept time and same time for keys on the keychain, router is gonna use key with higher key ID. Keychain Cisco key 2 and key string, let's say Cisco 1. It actually doesn't matter because key ID is different. This router is gonna use key ID 2 for IP OSPF authentication because all times lifetimes are default. Let's say I'm going to use this one, cryptographic algorithm HMAC-512. Let's see what we have. Debug IP OSPF adjacency. Let's wait, and you can see that mismatched authentication key, invalid cryptographic authentication key ID 0 on interface. Send with youngest key 0 key 2. So it's sending key ID 2 to this router R4 for authentication. Let's fix it. And debug all. Conf t keychain Cisco and no key 2. show key chain. Okay, and the last what I wanted to show, I want to show you why do we need to use not plain text authentication. Why is it better to use not plain text authentication, but for example HMAC, or let's say MD5. I'm going to sniff packets on these links and try to find my password, or let's see what we have on the link. I'm gonna open these captured packets in Wireshark. So let's see, this is our packet for plain text authentication, and as you can see we have our password Cisco in the hello packet. Let's try to open this one. For MD5 authentication, there is no password there is no password transferring between routers. Router use MD5 algorithm to hash key and message route update to create this cryptographic data to transfer between routers. So there is no key in open transferred between routers. This is everything what I wanted to show you today. Thank you very much for your attention. Thank you very much for watching this video today. I hope you enjoyed it. Please don't forget to subscribe to my channel and show your support to this video by hitting like button. I hope to see you soon in my next videos, but for now just ciao ciao.